Alright, so we're going to answer the question 6 now. It says, a rancher has 16 yards of fencing to enclose 3 adjacent rectangular corrals of equal area. Fencing is also used to separate the corrals. What are the dimensions for one of the individual corrals that will produce the largest total area, and what is the maximum area for the 3 corrals combined? So since we just have 16 yards of fencing for these 3 corrals, I like to imagine that, maybe the rancher was raising maybe gerbils and hedgehogs, but then once he got the hamsters, he'd really need to separate the 3. So what I'm going to do here is kind of walk through some different aspects of the problem so we can get a sense of the process of moving through this. So one thing to note is that we have 16 total yards. So each of these boxes is going to count as, each unit is going to be a yard. So we have 16 yards. So remember that yards are linear. So when we're talking about area, we're going to be talking about square units. So our area is going to be determined by how many squares, right? So we're going to have square yards. Okay, so some things to note: that we have this corral. We have these 4 vertical pieces that have to be included. You can see them here. And we have these, I chose to do it with each piece since my first question was about the dimensions of one corral. I chose to use my length as being one section here. You could use the whole section, but then you'd have to divide by 3 to figure out the dimensions. So I have these pieces here. So that's 6, and you can see my chunks down here. Now notice as my W changes, my W gets smaller, it's taking up a smaller amount of this total fencing. So I have a more fencing for the length. Okay, and if I take up a lot of fencing with the width, then I don't have much left over for the length. Now what I call width and length, you could name it differently, but I had the blue pieces being the width. Okay, and then the other thing to keep in mind is when it's asking for the total area, now that I've defined my length as 1 pin's worth, that I need 3 of these to be the total area. So that's why I have 3 WL. Alright, so the pieces that I need to kind of talk through, I want to eventually get to where I have a total area. You can see my kind of basing the different dimensions. I have my width and my length, and here I have my total area. You can see that it goes up, and then as I get kind of long and thin, then I'm going to have a lower area, and if I get really tall and thin again in the other direction, I have a low area. So somewhere in the middle I max out, and you can see from there that I'm going to max out at 8. But that's not something we would know ahead of time. So what do I need to do? Well, I know that my area is 3 of my width times my length. Now if I want to put that in terms of one variable, I need to have a relationship between my width and my length. And that, of course, comes from the total fencing. I know that if I add up all these pieces, I have to get to 16. We're assuming that using all of the fencing is going to give us the greatest value, and of course that's pretty straightforward. And so that tells me that, as my width gets smaller, I've got more length to deal with. And so I know that 4 of these W's plus 6 of these lengths should give me a total of 16. Well, I can rewrite that and say that my L value is equal to 16 minus the 4. In this case I wrote x because I'm going to plot it on an xy plane. but my W's are 4 W's, right? So I had 4 W's, and then I divided by 6 to get my L's. So I replaced my W with X, and then I replaced my L with an equivalent form now in terms of X. So I have this equation here. And you can see how that would plot on an XY. Now this, notice my input is X, which is my W, that's my width, and my output is area. Okay, so notice it goes up to 8 like we said before. So if I were to look at this, I have different values happening here. I can alternatively, instead of replacing my L value with something related to W, I could replace the W with something related to L. And if I did that, I would have this version here. Now notice here I have my WA. Notice the 2.3 comes from the width, and then my 7.82 is my area. You can see my area here, or my total area there. Likewise, over here, I have 1.133. That's my L value. That's the one chunk of green here. That's my L value. And then it gives me my area. So these are two different ways that I could approach this. Notice as I move. And notice another thing, as my W gets bigger, of course my L is getting smaller, so they're moving in opposite directions. And remember, we're talking about how many square yards for area. So here I'm at just over 5. 1, 2, 3, 4, 5, and some change. Okay, so that should give you a good sense of the different pieces that we have. So we have our total fencing, we have all those, and then we have to say, okay, well, how can we get, how would we know this area? Well, we have, notice we have an X in here and we have an X here, so we have a quadratic. And you can see, of course, that we have these parabolas that are opening down. So we just need to find the vertex. And so we can do that through a process of completing the square. And in the next video, I'll go ahead and kind of work out the algebra of that. But I wanted you to see kind of the concept as the W moves, what's happening, right? So we want to find the vertex. And then note that we have two dimensions, right? We have a length and a width, and then we also have an area. So we have those different pieces to deal with.